While you guys are working on page 4, just so you know, my coordinate template is a totally separate smartboard panel, so I can't keep flipping back and forth between page 4 and the template. So I'll be reading and you'll be reading off of page 4, but the template's going to always be up here. I need somebody to come up and plot the points A, which is 4, -3, and B, which is 4, 5. Go for it, John. You want to do point B? All right, so does someone, you want to do B? Yeah, we'll do B first. Go ahead. Five, 4. That's not 4, 5. You know what? Park. Don't even erase it. Ready? Park the marker. Park it. Drag the point where it's supposed to be. Knuckles, good. Yeah. Come on, baby. Come on. Hold on a minute. I think you're almost there. There you go. Yes, 4, 5. If you didn't do this, put the letter and always the coordinates. Oh yeah, okay. I'll change that in a minute. All right, somebody want to come up and do A? Geneve. Yeah, stay with blue. Sometimes the shadow gets in the way. Check, yes or no? Okay, if you've done it right, you've created a vertical line between A and B, right?
Yep.
Okay, just like yesterday, if you now go to the first question, they're going to ask you the distance. Well, if you remember what you did yesterday, you could take the coordinates or the values that are different, which is your y value, and you could add their absolute values. Or if you have trouble with that, for right now, you can do your leaps. Either way. The important thing is you have to arrive at the answer 8. Did you get 8?
Yep.
Okay, great. Now, I'm on question number 2 on page 4. I'm not going to flip back and forth. It says, draw a horizontal line segment from 4, -3, which is point A, that has a length of 12 units. Now, they don't tell you what direction to go, do they? All they tell you is horizontal. So once you are horizontal, or they tell you to go horizontal, there's 2 possibilities where the endpoint can be. And they want you to try to figure out what the 2 possibilities are, kind of building off of what you did in the problem set with that last question. So if you go 12 units to the left, where do you wind up? Point A, because that's where they want you to start at, 4, -3. Did you get that far? Do you need more time, or are you good? Because we could do it right now. Where do you wind up if you go to the left, Ben?
-8, -3.
How many have -8, -3? You know, let's just take a look at it so we can see it visually. I got to go 12 leaps. 1, 2, 3, 4, 5, 6, 7, and 8. They don't tell me to put a letter there, but I can put the points or the coordinate. And you wind up at -4. Oh, I only went 8 spots. Okay, thank you. That's 8, right? I got to go 4 more. Okay, and then you wind up at -8, -3. All right. What's the other possibility? And you got to kind of be a little abstract here, because if you go the other way, you kind of run out of room. Which is kind of really the gist of this whole page. Where do you wind up, Hannah? Do you know?
I can do the math. I know which way you go.
All right, which way do you go? How many spots? 12. Do you see that you do run out of room? You run out of room at, well, let's say you have 1, 2, 3, 4, 5, 6, 7, 8. You run out of room at 9. So now you got to think 10, 11, 12, and you got to kind of visualize where that's going to be. Geneve, what do you got? Yeah, you wind up, because remember, a coordinate plane goes on forever. You wind up at 16, negative 3.
Isn't it 15?
Well, you tell me. Look, you're at 4.
Oh, no, never mind.
You're at 4, and you're adding 12. Okay? You're adding 12 to 4, you get 16. So you could also do it adding your x value. That's another way you could do it. Kind of, you can model it on the coordinate plane, but you could also say, all right, well, wait a minute. I got to add 12 to my x value. My y value doesn't change because I'm staying in the same horizontal line. So out of those 2 points, now I'm on part 3 on page 4. Out of these 2 points, what's the better coordinate or what's the better point to use? Hunt, what do you think? Yeah, you want to use negative 8, 3 because it's visual and it stays on the coordinate plane. So again, I'm not going to be bouncing back and forth between this page, but your answer for 3A is negative 8, 3. And the reasoning is that it's on the coordinate plane. You can see it. All clear with that?
Yep.
We're going to build off of this here in a minute. Now, I'm going to clean this up a little bit because we need this. I'm going to go back to my blue, if I can do this, hopefully. Because I want my 2 points, A and B, with my coordinate values. Perfect. All right? Because we're going to now build onto this. All right, flip the page. Because you have your coordinate plane right next to the page. I don't, but you're going to go to page 5. And you go to step 4, and it says the 2 line segments that you have just drawn. Oh, wait, what did I miss? There's only 1 line segment. Where do I see 2 line? Oh. The second line segment is that point that we wanted, which was what? Negative, help me out. Negative 8. Negative 8, negative 3. Okay. I want you to, yeah, I'll bring it up in a minute. I want you to connect, trace along the line as straight as you can. Connect the dots between negative 8, come on, go up. I'm going to cheat. I'm going to use a little line tool. But you're going to connect point A and your negative 8, negative 3, and then connect AB, like that.
Right angle.
It is a right angle. Or it's 2 sides of a rectangle, agree?
Yep.
Do you know what a vertex is? Vertex is a fancy schmancy way of saying what? A corner, right? You have technically what's going to be, if you were to complete this, you have 3 corners or 3 vertices of a rectangle right now. Do you see them? You have negative 8, 3, which doesn't have, negative 8, negative 3, which doesn't have a letter, and you have A and B. Basically, a vertex, by definition, is where 2 line segments meet, where they intersect or where they join together. Yeah, Ben?
Actually, negative 8, negative 3, let me see.
Did they tell you to label it C?
Yeah.
Okay, great. I think that's easier anyway. Put C here. I'm fine with that. All right, so now, where would the coordinates have to be to complete the rectangle? RM, you want to come up and do it?
Found it.
Be negative 8, 5.
Pin it, and then label it, and call it D. And I'll worry about connecting, and I'll use the line tool, but I need you to write the coordinates in. Time out for a minute. If I got to connect this, I don't want the line going through it, so put the coordinates further off to the left so it's not in the way. Do you guys have negative 8, 5? Okay. as neatly as you can, complete the rectangle with your lines. All right? Really what the whole entire focus is of lesson 10 is completing shapes based on the coordinates they give you and then finding the perimeter in the area. Have you done it in 5th grade? Have you done perimeter?
Yeah.
Quick recap on perimeter. What's perimeter? No.
No, that's
Adding all the sides.
Right, you add up the lengths or the measurements of the sides. Perimeter, when you walk the perimeter of something, you're walking around the edge. If I were to ask you or tell you I need you guys to do a little train around the perimeter of the classroom, you would walk right around the edge of the classroom. Yeah, I was gonna play the song, but I'm not going to. Come on, ride the train.
Oh my god.
All right, never mind. Perimeter is the distance around the edge of a shape. What about area? Kat, what do you remember?
Side of something.
What's that?
Like any side of like.
Right, it's the amount or the amount of space within a two-dimensional shape. How do you figure out area? There's a formula that you use. Do you know it? James. Length times width. So essentially, if we could find the measurements of the sides, of all 4 sides, we can then determine perimeter and area. Okay, so let's take it through. If you go now to 5 on your sheet, the first thing they're going to ask you to do is write down the formula for perimeter. Now I do have to kind of switch and go to this, so I will. I'll come back to it. What is the formula for the area of for the perimeter of a rectangle? Crickets. I'll get you started. Perimeter equals, no, it's not. Length times width is your area. No, that's volume. Ben.
Length plus width plus height.
Remember, guys, how many sides are there in a rectangle? So you got to add 4 things. And I'm going to make it simple. Side plus side plus side plus side. Okay? You good? All right. Is everybody done?
Everyone done?
So, here. This is the supplement. You can work with your partner, but I want everybody doing their own sheet. There's 2 sides to it. And then that's it for today, guys. All right, so side plus side plus side plus side, right? I'm going to ask you guys first. I need you to calculate or determine on your coordinate plane template. I need to know the length of every side. So I'm not going to flip back just yet. I want you to find the length of each side of your rectangle from your coordinate plane. And you know what? Write it right on the coordinate plane. I want to know what the length is. I want to know what the width is. Up here is the lesson 10 supplement. Okay, and they're worth points. Yup. You'll need another coordinate plane. Give one to Zoda too, because you forgot to take one. All right, the longer side. Let's start with that. Is what, Andrew?
40.
He went. I think he went ahead. I just want to know the measurement of the sides. The longer side has a measurement of what? The longer side. Agreed. 12. The shorter side. All right. Let's take it step by step. You know what he did, right? He just said he found the answer. So it wasn't that far fetched. He just went ahead. But when you show your work, here's how I want you to show, because you're going to have to do this all in Mod 4 and Mod 5. I'm going to take my formula that I have here, and I'm going to substitute the values for each side. Now, you could substitute it in any order that you want. I'm going to do the 2 lengths first, followed by the 2 shorter sides, the widths. So all you do is substitute it, just like that. You got to show this, only because it comes into play when we do algebra, when we get to mods 4 and 5. And then Andrew is right. If you add it, you get 40. Do you know the units that we use? Assuming that I haven't given you any measurements, what do we say? Colin, you know? Not centimeters. I haven't told you anything's in centimeters. I'd have to tell you centimeters. I haven't told you inches.
Oh my god.
Just units. But not square units for perimeter. Perimeter is just in units. Guys that are coming in, you need this and you need one of these.
Wait, can't we just use the back of this?
You know what? Take a new one. Do me a favor too, Al. Bring this out into the hall so that it's out there so you guys are not coming in.
And the triangle.
Bring all of the 10s out there and bring coordinate planes out there for everybody so they're not coming back and forth. All right, continuing. Jamie B. Area of a rectangle again. A equals what? I'm going to use the dot from here on out so it doesn't get confused with a variable. Again, we're going to substitute our measurements for length and width. Length is always the longer side. Tree, what's the length?
12.
Correct. What's the width? Still. Multiply it together and you'll get your area. Joe. 96 is correct, but we don't call it units now for area. What should it be, John Capizzi? It's square units, which you can show by writing the word units with a little 2, which we call a superscript, upper right-hand corner, which means square units. The other way you could do it, too, is do something like this, and both are acceptable. But understand, you have to say square units to be accurate for area. Perimeter is just units. All right? All right, flip the page to 6. And do step 7. Do step 7 on your own. Don't go in ahead, though. Going back to the template. Do you have this? You could do it either way, because all I tell you is a diagonal line segment through the rectangle. So you could go C to B, or you can go A to D. All right, ready? Part A, 7A. What two geometrical figures have been created by the diagonal line? Trey. Agree? Triangles? Do you know the formula for the area of a triangle? We actually did it earlier in the year, but you forgot.
Length times height.
Well, length times height is kind of length times width. That's rectangle. Let me do it. I'll teach it to you. We have two triangles, right? So whatever the formula is for one, it's going to be for the other as well, right? Ready? Area of triangle. This is new. A equals 1/2 times length times width. Or that's the same thing, I'm going to put it below, as length times width divided by 2. Does that throw you off? You know what? I haven't taught you this as a division just yet. So leave it as length times width times 1/2. All right, let's do it. Oh, hold on a minute. 1/2 times, what was the length? Because the length hasn't changed. Yeah, it's still 12. Take a look at the triangle. It doesn't matter whether you're doing the top triangle or the bottom one. The width is still what? Still 8. Now, here's the only difference between a rectangle and a triangle. Dad, Ben, tell us. What do you do? What do you do? I know you have the answer. What do you do? How do you figure this out?
You take the answer from before and just divide by 2.
Yep, you take your 12 times 8, which is what?
6.
And divide it by 2. Tell me what you get. Everybody say it out loud together.
48.
Should get 48. What are the units? 48 what? Still square units. Okay, do the other triangle. Still want you to write the formula. Length times width times a half. Do we see that the length and the width of the second triangle are the same as the first triangle? That hasn't changed, has it? Therefore, what's the area of triangle 2? Also 48. Doesn't that kind of make sense? Because the two halves or the two triangles, when you put them together, make the entire rectangle. Which is really the answer to C and D. Okay, so C, what we notice is the areas are the same. And we can also put here that if we add the area together, you get the area of the rectangle. Got to squeeze it in here. I know. Area of each triangle adds up to the entire rectangle, or the area of the entire rectangle. Now see if you can make a connection. Let me hit pause for a minute while you get caught up. All right, part D. What connection can you make between the triangle and the rectangle? John. God, the triangle was 48. The rectangle was 96. Andrew. Right, the triangle, any triangle is going to be half the area of the entire rectangle. Which kind of makes sense because look at the difference between the two formulas. One's length times width, which is your area. One's 1/2 length times width. Remember I told you some of you will get it right away and some of you will not know even what to do. Break it down into steps. Do what you can do. They tell you the two vertices, the two corners of a rectangle. So now we're thinking, okay, we're going to make a rectangle. And two of my vertices are -6, -1, and 4, -1. Well, I want you to do that. Plot those points and connect those dots. Start off with that. I'm going to do the same thing here. Double check and make sure that your two vertices are correct. And let me ask you this, because then I'm going to actually have you do a little something in groups here. What is the length of that line segment? Joe?
10.
Does everybody agree 10? Put 10 in there so you see it's visual. Now we know that we have to make a rectangle, right?
Yep.
Do you agree opposite sides of a rectangle have the same length?
Yep.
Yes? And then the two shorter sides have to be equal, right?
Yep.
All right, so this is what I want you to do. See if you can figure out what they tell you now. They tell you the rectangle that you have to now complete has to have a perimeter, total perimeter of 26 units. And the rectangle that you draw has to be in all four quadrants. What are the coordinates of the two remaining vertices?
They're upside down.
Group up and do it. Because this is all you got left for today. I want to see if you can figure it out.